Hello everyone, I'm Saishnu Manohar from CSEB section, currently in 5th semester, here to present my tech talk for the course Web Application and Development. The topic I've selected for my tech talk presentation is Web Application Implementation with Machine Learning. Let's begin. Let's start up with the introduction to machine learning in web apps. Machine learning ML can enhance user experiences in web applications. It utilizes algorithms to analyze data patterns and make predictions. This integration is transforming the traditional web applications into intelligent systems. So basically in machine learning there are two types, as you can see in the diagram to my right. Machine learning are broadly divided into two types, which are supervised learning and unsupervised learning. Under supervised learning, there are two types, which are classification and regression. Under unsupervised learning, there are three types, which are clustering, dimensionality reduction, and density estimation. Benefits of machine learning in web applications. Machine learning can automate processes, reducing the need for human intervention. Machine learning can automate processes, reducing the need for human intervention. It enables personalized experiences, improving user engagement and retention. ML can also enhance decision making by providing data driven insights. Here are some of the applications of machine learning: automatic language translation, medical diagnosis, stock market trading, online fraud detection, virtual person assistant, email spam and malware filtering, self-driven cars, product recommendations, traffic prediction, speech recognition, image recognition. Here are some of the common use cases. Web applications use ML for recommendation systems in e-commerce. Chatbots powered by ML provide real-time customer support. Fraud detections use ML to analyze transaction patterns and flag anomalies. Key machine learning techniques. Supervised learning involves training models on labeled datasets. Unsupervised learning finds hidden patterns in unlabeled data. Reinforcement learning optimizes actions based on rewards and penalties. Data collection and preparation. Quality data is crucial for training effective machine learning models. Data should be cleaned and pre-processed to remove inconsistencies. A variety of sources can be utilized to gather relevant data for ML applications. Here are some of the factors which affects training data quality. The triangle diagram, which denotes supervisor, which include workforce, worker section, experience and training. Tools, which is basically technology, such as labeling tools and platform you use to communicate with your data workforce. And the process, which consists of operations such as business tools, communication protocols, and quality control. Choosing the right ML model. Selection of a ML model depends on the specific problem to be solved. Model ranges from relay regression for predictions to neural networks for complex tasks. Performance metrics should guide the choice of the most suitable model. Integration with web technologies. ML models can be integrated into web applications using APIs. Frameworks like TensorFlow.js allow models to run directly in the browser. Backend services can host models to provide predictions via RESTful APIs. Front-end development considerations. User interfaces should be designed to display ML outputs intuitively. Feedback mechanisms can help improve model performance over time. Responsive design is essential to ensure accessibility across devices. Backend development for ML applications. Scalable server infrastructure is necessary to handle ML workloads. Data structure solutions must accommodate large datasets efficiently. Security measures are vital to protect sensitive data during processing. Model training and validation. Training involves feeding data to the model and adjusting parameters. Validation sets help assess the model's performance before deployment. Cross-validation techniques can ensure robustness and prevent overfitting. As you can see in the diagram to my right, there's a original data sets which is predefined into three, which is training set, validation set, and test set. Training set is further deployed into using algorithms. This is sent into validation set, and validation set is again linked with the process between algorithm and predictive model. And at last, after cross validation and hyperparametric optimization, the predictive model is sent for final evaluation for test set. Basically, it uses test cases to run the predictive model. If it succeeds, then it's deployed. If it's failed, again it's run into various test cases to be solved. Continuous learning and adaptation. Machine learning models can improve over time with new data, implementing feedbacks loops over models to adapt new user behavior. Regularly retraining models maintain their accuracy and relevance. Challenges in implementation. Data privacy concerns can complicate the use of personal data for ML. Model transparency is crucial for user trust and regulatory compliance. Resource allocation for computational power can be a significant hurdle. Here is the process of how an ML implementation is done with data privacy concerns. Embedding data privacy, proliferating devices, increasing maintenance costs, access control is difficulty in many industries, getting visibility into all your data, a bad data culture, the ever increasing scale of data, a long list of regulations and documentation to follow. Tools and frameworks for ML development. Popular ML libraries include TensorFlow, PyTorch, and scikit-learn. Cloud platforms like AWS and Google Cloud offer scalable ML services. Development environments such as Jupyter notebooks facilitate experimentation. In the diagram, you can see there are many tools and frameworks which uses ML as their base, like TensorFlow, obviously PyTorch, scikit-learn, SparkML, Torch, Hugging Face, and Keras. Testing and quality assurance. Comprehensive testing ensures the ML model perform as intended. Edge cases should be identified to prevent model failure in real-world scenarios. User acceptance testing can gather feedback on the ML features implemented. Here is a definition diagram, or you can say a differences chart between testing and quality. Quality assurance and testing. The definitions of quality assurance is activities designed to ensure the software corresponds to the specifications. Testing is the process of exploring a system in order to find defects. The focus of quality assurance is to maintain quality control and meeting the requirements. The focus of testing is to improve system inspection and bug finding. The orientation of quality assurance is process oriented. The orientation of testing is product oriented. The activity type of quality assurance is preventive, whereas the activity type of testing is corrective. The aim of quality assurance is to assure the quality. The aim of testing is to control the quality. Deployment strategies. Continuous integration or continuous development (CI or CD) pipelines streamline updates. Containerization with Docker can simplify deployment across environments. Monitoring tools are essential to track model and performance post deployment. Here are some of the models which involve continuous deployment, which are build, test, accept and test, deploy to staging, deploy to production, and monitor the data. Performance monitoring and optimization. Regular performance checks can identify model drift over time. Optimization techniques can enhance model efficiency and speed. User analytics can provide insights into how the ML features are utilized. So, performance monitoring is basically done through two steps, which is offline and online. Under online, there are three stages, which are deploy, monitor, and analyze. Under offline, there are three steps, which are validate, train, and improve. Ethical considerations in ML. Bias in data can lead to unfair outcomes in machine learning applications. Transparency in algorithms is crucial for ethical compliance. Users should be informed about how the data is used for ML purposes. Future trends in ML and web applications. Advances in natural language processing are enhancing user interaction. Federated learning allows for model training without compromising user privacy. The integration of ML and IoT is expected to create more intelligent applications. case studies of successful applications. Netflix recommendation engine exemplifies effective ML and user engagement. Amazon uses ML for personalized shopping experiences and inventory management. Spotify employs ML for music recommendations and playlist generation. Conclusion and next steps. The integration of machine learning in web applications is a game changer. Organizations should invest in ML capabilities to stay competitive. Continued learning and adaptation will be key to successful ML implementation. The presentation provides a comprehensive overview of the implementing machine learning in web applications, addressing the key aspects, benefits, challenges, and future trends. So, thus, we can see the integration of AI and machine learning in web development is coming into near future and could be a game changing for the field of web development application. And here we are at the end of the presentation. Hope you liked my presentation. Thank you for your time and hope you have grasped a bit of knowledge about the impact of machine learning in web application development studies. Thank you.